Okay, so have you guys had a chance to look at what this week's lab is on? So you've seen it? Okay, but you guys haven't? Alright. No, that was last week. This week. Or like when you're gonna start on Friday. Okay, so I'll describe it to you because all that I'm doing for today is to help work through how to solve that problem. So it is our second week on data visualization. And like Mason was saying last week, it was making those graphs. And that is due this Friday. And then starting on Friday is visualization 2, which one part of it is making one other type of graph, a scatter plot. And then the other part is a problem using images. So basically, images are a part of data visualization. Okay. So the problem that you're going to solve is you have 3 sample images that I've provided. So like say this is your image, right? And in all 3 of the images, there's a tennis ball. Your goal is to return the location of the center of the tennis ball. Okay? So the question is, how can we solve this with a function? Any ideas?
Are we doing it?
You're finding a tennis ball in the image. Yeah.
I'm thinking of
Uh-huh.
somehow I have to like scan the image and then just like, what's the most number of like green pixels next to each other? Probably divide that in half.
Okay. So part of it is very good, and I think if the whole thing might work, but it might be a little bit uh more than what is necessary. So the part that's I want to focus on that you said was we want to find green, right? Tennis balls are like a very, very light green, almost yellow color, right? So how can we find green in an image? What is green? Uh-huh,
PV of it,
uh-huh.
like whatever's. Does it, would the background be like different color or?
The 3 that I provided, I made sure are very different than the tennis ball. Like one is a blue background. One has green because the tennis court is green, but it's a very,
Different green.
yeah, it's very dark.
So do you look for the particular color, like the RGB like combination of it?
So let's first we need to first figure out what color we should say. In this range, this is like the color of tennis balls. So like my say R L H and green low green, green, decline. And B low, B, B. High. Right, so like my red value is between here, green is also between this, and blue is between this. If that is the case, then I have a color that is most likely the tennis ball. So now that I know what color to look for, what am I going to do with this information? Hmm? And what should we do if we find a match?
Should we like keep track of the position of the pixels?
So how are we gonna keep track?
I mean, will we be able to just like make a grid or like lay out the whole image like and like put it up in pixels or just like find the position based on like maybe at the origin in the middle and then the distance from there?
Let's say. So what is the image when you load it into MATLAB,
Oh, yeah. Oh,
right?
yeah.
What is it? What kind of array? It's more than 2D because it has one value at each position for red, one at each position for green, one at each position for blue. So it has, it's 3 dimensions, right? So we are going to loop through them, figure out at this position, is red in this range, is green in this range, is blue in this range? And we can just make a new array, right? A 2D array that is the same size as the image part of the 3D array for the image, right? We just want the locations. So when we find which pixels match, we're then going to input 1 if pixel matches, else 0. So now you'll have kind of like a mask of your image. Right? This is where the ball is, right? So everywhere here, all of the values are 0, right? And then here where the ball is, we have a bunch of 1s. Okay. So now we have this cluster of 1s that indicates where in the image the ball is. But we need to find the center of the ball. So what can we do with this array to get the center?
Yeah, get the size of the array and then like put the middle array and then divide it by 2 or something like that.
But this is the size of my array.
Or like, like where the input is one,
Uh-huh.
and like find the size of that. Like, get the, or like divide,
How would I find the size of that?
just subtract from like, from the big array to like the ball, like subtract them or like find the difference between them or something, right?
Okay. I think this could work.
Or if anything, you can like find the pixels that are like from the top and bottom of it and like the size and like, like find the difference or something like that.
Yeah. So you're suggesting kind of like a two-step process. First, find maybe the widest row,
Yeah, yeah.
right? And then what is the position of this one? What is the position of this one? Give me the middle. Because I presumably am a round ball. So the widest row is the center row. And then I need to also find the widest column, find the center there. And then that is the center of my ball. Right? So that's one thing that we can do. There's a faster way to do this. This would work though. But it would require, oh, like 3 nested for loops, something like that. There's a faster way to do this. Add the ones or something else. Yes,
You take the positions of all of those ones and average them out.
yes. So also this would be a two-step process, but we can get the positions of the ones very quickly, right? Because we can just do the comparison if one, right? It returns where the array was one, right? So if we get all the positions of all of the x positions of the ones, so 2 steps. It's all x of ones and average it. Get all y positions of ones, then average. And you're done. Return x av y av. That's the center of your ball. Right? Make sense? So you're gonna figure out what is a tolerance range of green where I can find the ball, because the ball is not going to be this one particular color. And then create this mask with an array of zeros where green is not found, 1 where green is found. And then get the x position of all of the ones, average it, get the y position of all of the ones, average it, and you get the center of your ball. Okay? So this is the larger portion of this week's lab. The other portion is just create a scatter plots, very similar to last week's lab where you made a bar plots and line graph, right? So are we clear on how to find this ball? Okay. So the other thing to mention is, again, we're going to follow our coding practices that we've been learning. So this should not be one function, right? Should be a few that you're gonna then call into a higher level function. That would be find ball or get center of ball, something like that. And then because of this segmentation, we can also test each smaller part individually. So we can be sure that each part is functioning as intended before we put it all together. And then debugging is harder for figuring out everything as one function. Right. So this is what I wanted to cover today. And if you guys don't have any other questions, you can have the rest of the time to work on the data visualization lab 1 if you have not finished. It's not due until Friday before class. Code is 993.